Welcome back, guys. In this second video for SPSC lecturer past paper of 2021, I'll be discussing rest of the questions from question number 21 to question number 40. And you know very well, out of those 50 questions, the 40 questions are related to mathematics. And 20 questions are done in the previous video, and I'm going to discuss the last 20 questions today. And obviously, these won't take so much time because the questions are not that much technical as we have questions in GRE. So let us start. Question number 21 is F is a vector field. Then the divergence of F is either a vector quantity or a scalar quantity or a tensor of rank 1 or none of these. So let me tell you, like, we have three different operators which we apply on either vector fields or scalar fields, it doesn't matter. But in the usual convention, we have gradient and we have divergence and we have curl operator. In these, all the operators, what is the input and what is the usual output? So input is a scalar field in gradient and output is a vector field. So in gradient, you give a scalar field and it gives you a vector field at a certain point. You can apply gradient on a vector field as well, but the result would be a matrix. And we usually call it's a tensor of rank 2. So scalar is also called tensor of rank 0 and vector quantity is also called tensor of rank 1. So obviously these two options are same thing. So to me, like none of these two options is the correct option. So the correct option is either B or D. So let's see. And the divergence is you give it a vector field and the result is a scalar field. So we have to find out divergence of F. F is a vector field. The result should be a scalar field. So our answer is B. I'm not going in technical details. So when you have any MCQ here, let's say MCQ 21, and you are revising this whole paper, so I advise you to give yourself time properly. Either skim through these all the MCQs, that depends upon you, or just go and take a book of vector analysis and see what is gradient operator, what is divergence operator, and what is curl operator. It depends, or you can just keep these all the things in your mind. So in curl, so let me write it correctly. So it's a curl in which the input is a vector field the output is a vector field. So for this question, obviously the correct option is B. Okay, so I think this is not that much technical question. Let us move ahead. MCQ number 22 is which expression expresses the distribution law of Boolean algebra? So basically none of these is what we call the distribution law of Boolean algebra. Actually, option A is distribution law, but it's not the distribution law in Boolean algebra. In Boolean algebra, the distribution law states like this. A plus B times C is A plus B times A plus C. This is distribution law in Boolean algebra, so our option is none of these. And why this is so, let me tell you. In Boolean algebra, we denote sum by R and we denote this product by AND. We can just distribute it, so it will give us A or B and A or C. A or B is A plus B multiplied by A plus C. So you can see that, okay, this thing is equal to this thing by using these laws from Boolean algebra. So correct option in this case is D. It might not be the correct option in key, but you can check over there. MCQ number 23 is, what is the other name of Jacobi's method? It's not a common question, but you will find this maybe in some good books or research papers, that another name of Jacobi's method is simultaneous displacement method. This Jacobi's method is a method to solve system of equations. It is an indirect method or iterative method, and it has another name which is very common. And the reason behind this is, when you solve a matrix, you get all the entries from x1 to xn. You get all the entries in their first iteration by using the previous iteration at first place. And the next iteration, you use all the previous values. You don't use any new value. So you are moving from x1 to x2 and then x3. So simultaneously, you are displacing all. From first iteration, you are jumping towards the second iteration and so on. Maybe there might be another reason behind that, but like it is just a name, so we don't need to worry about, okay, what is the justification behind the name? Okay, so let us move ahead. MCQ number 24 is, which of the following numerical method has quadratic convergence? So let me tell you, only one method in these has some sort of good convergence that we call quadratic convergence, and that is Newton-Raphson. So the answer would be A, but all other methods are not quadratically convergent. There's a problem with bisection. Sometimes we call it, it's not. Yeah, it's not among those methods where you can show quadratic or linear convergence. I think regular falsy has linear convergence, and secant has superlinear convergence. Linear means like its order of convergence is 1, and this one is roughly 1.61, I think, but you can further check these things. But Newton-Raphson has order of convergence too. That's why we call it quadratic convergence. What do you mean by this? Basically, error at step n plus 1 is bounded by some constant time error at step n to the power p. And this power p is what we call order. In case of Newton-Raphson, this p is equal to 2. In case of regular falsy, it's 1. In case of secant method, it's 1.61. Yeah, so this p is what we call the order. It's 2 in the case of Newton-Raphson. We can prove this thing, but there's a lengthy proof for this. And for MCQ's point of view, you are supposed to just keep these all the things in your mind, nothing else. MCQ number 25, which of the following is valid implication? This is really a very simple question, and everyone must know this thing. It is, every differentiable function must be continuous. So if a function is differentiable, it must be continuous. I can give one example that, okay, if a function is continuous, it is not necessarily differentiable. And the famous example is this mod of x function. You can see this is a kink, and at this point, the function is not differentiable. And if a function is integrable, then it must be continuous, not necessarily, because you can integrate the functions which are not continuous. You can integrate them easily, because if I give you a function which looks like this, I ask you what is the area below the curve between A and B, you can find it out easily. Like you will say, okay, I'll find this area first from here to here. Then I'll find this area from here to here. And you can find out area below the curve easily. That's not a problem. If a function is continuous, it must be smooth. Smooth means see infinity here. Like if it is continuous, it means it is once differentiable, twice differentiable, thrice differentiable. No, never. Okay, so correct option is B. MCQ number 26. This is really like a very simple question. I don't think why they have given this question here. A is any matrix and B is equal to A transpose. Like I give you any matrix and you transpose it, it will be any general matrix again. It might not, it might have a special property, but in general it's not. So it's another general matrix. This might not be correct in the key, but this is the correct option. The question is why it is skew symmetric, why it is symmetric about the secondary diagonal, why it is symmetric. No, if A is symmetric, then A transpose is also symmetric. But it is not given that A matrix is symmetric. It is given that where A is any matrix. So it's option D. MCQ number 27. The number of positive divisors of 500. So there's a function denoted by tau. So tau of some number prime p1 times p2 to the power n1 n2 is n1 plus 1 n2 plus 2 plus 1. So this is the formula to find out the number of divisors of any number. What you do, you find the prime factorization, p1 to some power, p2 to some power, p3 to some power, p4 to some power, and so on. You find the prime factorization of the number, and then you check that, okay, like this tau function gives you the number of divisors, the number of positive divisors, because negative numbers also divide, and this doubles the quantity. So what do I need to do? I need to find out the factors of 500. And obviously, I think I'm going to write the factors. Not going to find out the factors of 500. I think I have those. So it's 2 to the 2 and 5 to the 3. These are the prime factorization of 500, and you can take these numbers 2 plus 1 and 3 plus 1. This becomes 3 times 4, which becomes 12. So total positive divisors of 500 are 12. So you have to count how many numbers divide 500. So it's 1, 2, and 4, and up to 500. So there are 12 numbers in total that divide 500, and you can count these easily. But this is the formula to do this thing. MCQ number 28. There's an issue with this because it says that we have a quadratic function parabolic graph is concave down. If what happens? So ax square plus bx plus c is some sort of quadratic function. If where a is greater than 0, the parabola is like a cup of parabola, it's concave up, and a is less than 0, then it is concave down. So for concave down, a should be less than 0, and none of these options tell that a is less than 0. I mean, this option should be a is less than 0, but I don't think like why they have given these options. There might be a typo or there is something else, but I think the last option should be a is less than 0, which is going to be the correct option. So a is greater than 0, it means it is concave up. A is less than 0, it is concave down. And this is the general form of quadratic function. Okay. MCQ number 29. Which of the following is correct statement of De Morgan's law? So basically you have to look for, if there is intersection on one side, there should be union on another side. Intersection, union, or union, intersection. But rest of the other options are not correct. So this is the correct option, which is C. So this is like very basic question which you can find in any metric class mathematics book, or even in class 8 books. You can find this thing easily. Okay, MCQ number 30 is, what is the determinant of this matrix? So determinant you can find out easily by using any way, the Saros rule, or there is some sort of other expansion. These are just fancy names. Otherwise, there's a method you can apply that thing. But let me tell you, if any two rows are just simply multiple of one another, or in other words, you can see if two columns are same, or two rows are multiple of one another, then the determinant is 0. You don't need to calculate that. If you are going to calculate and then writing the answer, it's also true. It's also going to be correct, but it will just waste your time. So any two columns are same, or rows are multiple of one another, you're done. The determinant is going to be 0. Okay, MCQ number 31. The degree of any vertex of a graph is, so if I have any graph, let's say, let me draw a graph. So the question is, what is the degree of this vertex? So how many edges are connected to it? So there are 3 edges. So the degree of this one is, degree of this vertex is 3. Degree of this is 2. This is 3, and this is 2. So what should be the correct option? It's number of edges. I think there is some sort of number of edges incident with that vertex. So with this vertex, how many edges are incident? So 1, 2, 3. This is going to be the degree of that vertex. So this is the correct option. MCQ number 32. There is a region which is not simply connected is called. So which is not simply connected is called multiply connected or multi-connected, or maybe there is a similar word. So this is mostly used in complex analysis. A simple region is like this. If I give you any region, you just shrink it down. If you just squeeze it down, it becomes a point. Then we call it a simply connected region. A multiple connected region is like this. I give you some sort of annulus like this. It is multiply connected region. So this is the region where I'm highlighting with this yellow color. So if you squeeze it down, it's not going to be a point. It is not going to be a point. It would be a small circle if you are going to squeeze it down. Or it can be just maybe some crazy portions like this. Maybe like this. But this can be broken into a point as well when you squeeze it. But if I give you two circles here now, this is not simply connected region. So there might be different examples. This is simply connected region. Because topologically this square is a circle, and you squeeze a circle, you get a point. So this is simply connected. Okay, so the correct option is C. MCQ number 33. The inverse of 3 in this group under multiplication mod 7 is. So I need to find out the inverse, so I don't need to work hard on this. I need to just check these all the options. I'll take this 3 and multiply with 3. 3 times 3 is equal to 9, but in mod 7 this is equivalent to. So you divide 9 by 7. What is the remainder? 2. You will write that. So in mod 7 this is equal to 2. And you will check for other options. 3 times 1 is 3. In mod 7 it is 3. 3 times 5 is 15. In mod 7 it's 1, because 2 times 7 is 14, and 15 minus 14 is going to be 1. 3 times 4 is 12. This is equivalent to 5. So you can see in this option, there is 5, which gives you 1. So when 5 is multiplied to 3, you get 15, and which is equivalent to 1. Then 3 and 5 are inverses of each other. 3 and 5 are inverses of each other. So the inverse of 3 is going to be 5. So you can just check all the options as well. MCQ number 34 is just you need to differentiate this function. So you just differentiate the outer function first. So the derivative of sine is cos log 2x m multiplied by the derivative of interior function, that is log 2x, becomes 1 over 2x. And the derivative of most interior function is 2. So you cancel these. So you get cos log 2x divided by x. So this is the option which is going to be option B. Yeah. So it's really simple. MCQ number 35 is the polar form of the complex number x plus iy. So what is the polar form? So when you have complex plane, where you have any complex number x plus iy, so there is some sort of distance from the origin, and there is a height, and there's a base. This base is x, this height is y, and this angle is theta. So by using trigonometric ratios, you can write that, okay, cos theta and sine theta, you know very well, perpendicular upon hypotenuse and base upon hypotenuse or whatever. So x over r, and this is going to be y over r. This will give me x is equal to r cos theta, and this will give me y is equal to r sine theta. And if you substitute in this one, you will get r cos theta plus ir sine theta. So this is going to be the correct option for the polar form of this complex number. This is very famous. MCQ number 36 is the eigenvalues. So there are two things. Either you find the eigenvalues, or you just check some sort of properties that, okay, if the properties are satisfied, you're done. So the first thing is that you need to find out what is going to be the determinant of the matrix. So determinant of the matrix is this product, which is 0, minus that product is minus 2, which is 2. So you need to find out what two numbers are giving you the product 2. So the determinant of a matrix is equal to the product of eigenvalues. So this product is 2, and this product is 2, and this product is -2, -2. That's why I'm going to cancel these out. Now the another thing is you will find out the trace of the matrix. Trace is the sum along the diagonals, like this sum. So the sum would be 0 minus 3 is minus 3. Now you check that, okay, what of those two eigenvalues give you some -3. So that is option A. Hence the correct option is A. In other words, you can also find out the eigenvalues explicitly by using this method, which is determinant of A minus lambda I. So determinant of A is 0, 1, -2, -3, minus lambda I is identity 1, 0, 0, 1. And setting this equal to 0. So this would be negative lambda and 1, -2, -3 minus lambda is equal to 0 implies you just need to find out the determinant now. Negative lambda, -3, negative lambda plus 2 equals 0. And when you simplify it further, lambda square plus 3 lambda plus 2 equals 0. And when you solve it further, this becomes lambda plus 1 and lambda plus 2 equals 0 after factorization. This will give you the value of lambda to be negative 1 and negative 2. Negative 1 and negative 2, and you can check this is your option. So either you can find by using this whole way, or you can check these two properties, determinant and trace. So for 2 by 2 matrices, determinant trace also works when you want to check, because options are given to you. You just need to check and you just need to tick the correct option. So this saves your time a lot. Okay. MCQ number 37, which of the following is true statement in normed space? So it's very common question. And the true statement is every convergent sequence is Cauchy, but every Cauchy sequence is not convergent. I'm going to tell you what do you mean by that thing. So every Cauchy sequence is not convergent. So you take a sequence which is sum of these 1 over n's. It is a series, but I'm talking about partial sums. So it is Cauchy, but it is not convergent. But if you take any convergent sequence, let's say 1 over n square is a convergent sequence, it will be Cauchy as well, you can check. And option C is every bounded sequence is Cauchy. So I give you a bounded sequence, which is an is negative 1 to the n. So what are the terms? Negative 1, positive 1, negative 1, positive 1. You just put the value of n to be 1, 2, 3, you will get these terms. So this sequence is not Cauchy, and even it is not convergent, so C and D are incorrect. Convergent means they should converge to a fixed value, but here the values are alternating, negative 1, positive 1, negative 1, positive 1. And they are not Cauchy because the difference between two terms cannot be made as small as possible, because the difference between 1 and negative 1 is 2. So you cannot make that difference to be near to 0, never. So like this is very common question. Every convergent sequence is Cauchy. Every Cauchy sequence is not convergent in general. But there are most of the cases where it is convergent if you take a complete space. Yeah, but we are not going in that much detail. MCQ number 38. Let me tell you, there is a typo here. Sorry. There's a typo here. So I'm going to write the question again. This is limit x goes to infinity, x sine with angle 15 over x. So it is sine 15 over x. This is sine, and the angle is 15 over x. I will apply some transformation. I'll let y to be 15 over x for simplicity. So then I take x there and y here, then x would be equal to 15 over y. And if I substitute these values, x is 15 over y, sine 15 over x is y. And as x goes to infinity, you can put here infinity, then y goes to 0. So limit y goes to 0. So you can transform the limits in this way as well easily. Now 15 is a constant, I can take it out. Limit y goes to 0, sine y over y. And you know very well this is an identity which is equal to, this is equal to 1. So 15 times 1 is going to be 15. So my answer is 15. Yeah. Just I have applied this identity which is equal to 1 and I'm done. And I applied this transformation, I change the limits. That's it. This is MCQ number 38. So MCQ number 39 is the probability distribution whose mean and standard deviation are equal is. So we discussed last time one whose mean and variance equal is Poisson. The probability distribution whose mean and standard deviation are equal is exponential distribution. So let me tell you what is the PDF of this. F of x is equal to probability that random variable takes values x is lambda e to the negative lambda x for x greater than or equal to 0 and 0 when x less than 0. Let me just verify it. Yeah. So when you find expectation of this PDF, it's 1 over lambda, and variance of this one is 1 over lambda square. But you know very well, standard deviation is square root of variance, which is square root of 1 over lambda square, which is 1 over lambda. So expectation and standard deviation are equal for this exponential distribution. So expectation is other name for mean, and standard deviation is this standard deviation that we got so far. Okay, so like I told you what is expectation, and like let me tell you what is the idea and how you can find the expectation, also called mean. It's the integral from negative infinity to positive infinity x times f of x the PDF of their distribution. So I will write only 0 to infinity. Why? Because when x is less than 0, it is going to be 0. So no need to mention that thing. X times lambda e to the negative lambda x dx. Everyone knows integration by parts, and these all the things. You can simplify it and you will get the value 1 over lambda. I'm not going to explain it further to you. And for variance, so negative infinity to infinity, x minus expectation, which is 1 over lambda, we find now, times f of x dx. You put the value. Again, I'm going from 0 to infinity because otherwise it's 0. X minus 1 over lambda, sorry, this is square. F of x is lambda e to the negative lambda x dx. Again, you know very well how to integrate. You will square this term and you will integrate each term and you will apply by parts. And finally, you will get this variance. And from variance, you can take a square root and that will be your standard deviation. So you can get the mean, variance, and standard deviation of any PDF, either continuous or discrete. If it is continuous, you will apply integral. If it is discrete, you will apply summation, but it all depends. So this is like, these are really basic things in probability theory. Let us go ahead. Wow, the last question. So what equation does the velocity potential of an incompressible fluid satisfy? So let me tell you, for an incompressible fluid, if V is velocity of the fluid, then it must satisfy this divergence free condition. It means divergence is always 0 when V is velocity of an incompressible fluid. This shows some sort of continuity assumption. But when velocity is equal to grade of some velocity potential, so velocity potential is denoted by some phi. And if this velocity potential function exists, then velocity is equal to grade of that function phi. Now I will put the value of V in this equation over here. This will give me this thing. And del dot del becomes del square. And this is what we call Laplace's equation. Done, nothing else. You can also write this thing in this way. So this del square is also written in this way. We mostly use that thing. So this was MCQ number 40. So this completes the questions related to SPSC lecturer past paper of 2021. So next time I will try to discuss maybe some papers related to STS or Caribbean University or Federal Public Service Commission. So till then, see you and goodbye.